Great. All right. So we're a new group and looking for collaborators. We're based at Children's Hospital, but have collaborators with MIT and Martino Center. Our main focus is early brain development in the fetal neonatal brain. And basically what we're really interested in is improving the cognitive, neurological, and behavioral outcomes of children. And what we're looking at, or where we're placing ourselves, is at the interface between the biology and the imaging, really understanding that link so we can really hope to guide treatments moving forward. And we focus on non-significant risk technologies, MRI, NIRS, and MEG. You'll hear a little bit about NIRS and MEG later today, so I'm going to focus on the MRI. And in the background, we have a computational infrastructure we've put in place as well, too, with a high-performance computing center, so we can try to get the data analysis back to the clinician as quickly as possible. With Larry Wald, we've been developing MRI coils that are tailored to the size of the kids that we see. So here are some of the, whoops, which one's that? Whoops, sorry.
This is an IQ test.
I know, so, it is.
Yeah, so here where the light supposedly is.
Okay, let's go back. Oh, there we go. So we can build these coils, because the first thing to start out with is the best data possible. So getting the coils the size of the premature baby's heads and not using standard adult coils to get the data acquisition is one of the projects. And a second project is also bringing the MRI close to the baby. So we've got collaborations with GE to develop a mini MRI that's actually going to fit in the closet within the ICU. And we're hoping to develop that into a commercial system so MR imaging becomes more standard in this infant population. There's a lot of measures that we're developing to better characterize early brain growth and ideally detect divergences very early on so we can get in with treatments and monitor. So this also begins at the fetal stage where we start to look at the surfaces and extract the curvature measures so we can start to look at how the brains fold during early development and again get measures. And the actually handout that you have is additional curvature measures, these similarity measures we've been developing from KIHO-M. It's the handout you have in your talk, which is, again, looking at whether we can come up with measures to say whether kids or especially when I'm doing fetal imaging, is this 20-week-old equivalent to other 20 weeks old, or is it unlike other 20-week-olds that are normal? We go into diffusion imaging because we're really interested in early brain development and understanding how migration occurs, and we've done past specimens to look at radial and tangential myelination. We're also correlating that with immunohistochemistry and histology to better understand what are the biological processes that are driving the images we're studying, because we have to go down to that level if we're really going to make clinical reads on these cases or affect change, a treatment, or in early fetal imaging, it's sometimes difficult questions of termination. So we want to know that we're right and we understand what's driving the signals that we're interpreting. This diffusion imaging, we're also now starting to move into the in vivo specimens, so we do this in our clinical studies. And next thing on my list is to talk Larry to work with us on a fetal coil and to try to push this to 3T so we can really change how we do fetal imaging. We're very much interested in developing connectivity, so we've looked at structural connectivity and modulation with myelination, and we're overlaying functional connectivity measures on that as well, too. So I just wanted to end up and say that, again, we're a pretty large group with multiple modalities. Again, we collaborate very closely with many people in this room, and we'd love to work with anybody who's interested in better understanding early brain development. Thank you.